Hello students, welcome to the fourth lecture on the topic differential equation. So till now we have solved first order differential equation with the help of the methods which are variable separable, reducible to variable separable, homogeneous, reducible to homogeneous. So in this lecture we will discuss exact differential equation, like what are exact differential equation and how we can get the solutions for the exact differential equations. So let's begin. So before knowing what is exact differential equation, we should know what do you mean by total differential. So I'll just write the definition of total differential. So what is total differential? So let f be the function of x and y and it is continuous and having first order partial derivatives in some domain D. Then the total differential of f is given as, and this is mainly denoted by df. So I'll write, so it is given as df is equal to del f by del x into dx plus del f by del y dy. So basically it represents the change in the value of f with respect to the change in the value of x and y. So now let us see what do you mean by exact differential equation. So suppose if m and n are functions of x and y, then this equation is called exact when there exists a function f x comma y, that is f is a function of x and y, such that d of, that is total differential of xy, is equal to this. So you have a differential equation like this. Okay, now if you can find some function f such that this is equal to this, then you will say that this differential equation is exact. So now if you can see that I can write this equation as I have defined the total differential, I have this thing. Okay, now this is equal to this, so I'll write that is, this will imply this. And now if you can see and equate from both left hand side and right hand side, what will you get? You are getting, suppose I give it equation number 1, and then I'm getting, comparing both the side of equation number 1, what I am getting? I am getting del f by del x is equal to m, I give it equation number 2, and del f by del y is equal to capital N. This is my equation number 3. So now if you differentiate this with respect to y and this with respect to x, then what will you get? Now I'll just try differentiate 3 with respect to x and differentiate 2 with respect to y. What I am getting? Del square f by del y del x is equal to del m by del y. Okay, this I call it as equation number 4, and if you differentiate you will get, now since both this m and n are continuous functions, so from 4 and 5 I call this as equation number 5. So from 4 and 5 what I am getting? I am getting del m by del y is equal to del n by del x. So it is an important equation because it tells about the exactness of the differential equation. So let's write down it more clearly, a test for exactness. So consider a first order differential equation like this. I have a differential equation, that is m is a function of xy and n is also a function of x and y is equal to 0. This I have a differential equation. Now where m and n has continuous first order partial derivatives in some domain D, then differential equation 1 will be exact if and only if this condition holds true. Del m by del y is equal to del n by del x. So this is the necessary and sufficient condition for differential equation 1 to be exact. Now let us see few example where we have to check that whether the equations is exact or not, and then we will talk about how we can find the solution of the exact differential equation. So suppose that I have a differential equation y square dx plus 2xy dy is equal to 0. Now if you compare this with this equation, you can see that here m and n are what? Here m is y square and n is 2xy. Okay. Now for exactness, what is our necessary and sufficient condition? That del m by del y, that is equal to 2y, and del n by del x is equal to, that is again you can see that it is 2y. So you can see this implies that del m by del y is equal to del n by del x, and therefore the equation is exact differential equation. Okay. Now let's see how we can find out the solution of the exact differential equation. So suppose that you have a differential equation like this and is exact, then you know that there must exist a function f(x, y), that is a function of x and y, such that this thing should hold. This I have told you earlier, that you should find a function f such that d of f should be equal to this. So you can see that put 2 in 1, we get del f by del x dx plus del f by del y dy is equal to 0, and this implies that your d of f of x, y is equal to 0, and this implies that f of x, y is equal to c. So this will be the general solution of the exact differential equation. So this is, I will write, and here c is any constant, so I'll write it down, c is constant, and this is the general solution of exact differential equation. Okay, so now let's solve few questions on this of the want to find the solution of the exact differential equation. So how we can find this function f, this is a function f, and this will be the solution. So how we can find out this f, let's see. Okay, so I'll write test whether the following ordinary differential equation is exact or not, and also solve if it is exact. So this is the differential equation. Okay, so let's see how we can do. So comparing this equation with m dx plus n dy equal to 0. So I'll write what we have. We have m is equal to e to the power y, and what we will get, we will have n. So what we will have, we will have n equal to x e to the power y plus 2y. Now you know what is the conditions for exactness, that you need to find out del m by del y, which is equal to e to the power y, and what about del n by del x? This will be again e to the power y. Now since del m by del y is equal to del n by del x, therefore the equation is exact. Equation 1 is exact. No problem in this, like you just need to find out that if these two are equal, then your given differential equation is exact. So I'll now tell you how can you find out the solution for the exact differential equation. Now till this you have only known that my equation 1 is exact. Now what is the solution? That is, you need to find out the value of f, the function f, so that you can write down the solution like this, that f is equal to c will be the solution of the differential equation. So what is how to find this function f? So let's see. So I will give you two methods for solving this exact differential equation. So first one is bit lengthy technique, and then I'll give you the shortcut technique which you can use like every time, but just once I will use the lengthy technique to solve the exact differential equation. Now you have known that since the equation is exact, so you have this, you know that you will get a function f that is equal to this, and this will be equal to this. Okay, so this implies that what, del f by del x is equal to m, and del f by del y is equal to n. And what does this gives you? Del f by del x is equal to e to the power y, because you have seen that your m is e to the power y. And what will be the value of del f by del y? It will be this x e to the power x plus 2y. Okay, so now what you have to do, you have to integrate this with respect to x. What we will get? We will get f is equal to e to the power, obviously the y will be treated as constant, and you will get something like this. And now if you differentiate this equation, this one, with respect to y, what will you get? You will get e to the power y into x plus g dash y is equal to del f by del y. What you have done, you have only differentiated this with respect to y. Now just see this equation and this equation. So if I call it like equation 1 and this one as equation number 2. So from equation 1 and 2, what we will have? We will have x e to the power y plus 2y is equal to e to the power x plus g dash y. Okay, this implies that g dash y is equal to 2y. Now what we need to do, we need to integrate this one to get our function gy. So integrating, what we will get? We will get this. Now putting this value of gy in your equation number, call it as equation number 3. So putting the value gy in equation 3, what I am getting? I am getting f is equal to e to the power y into x plus y square plus a. Now you know that the given ODE is what? df is equal to 0. So I'll write the given ODE is df is equal to 0. You know that this is equal to m dx plus n dy equal to 0. So I write down df is equal to 0 and the solution is, I already discussed, and the solution is f is equal to some constant. Okay, so therefore what I will get? I will get e to the power x plus y square plus a is equal to some constant. You can write this as e to the power y into x plus y square is equal to some constant b by merging these two constants. So this will be the answer for the solution of your given differential equation, this. So now you can see that this method was a bit lengthy method to find out the solution for the exact differential equation. So now I will give you a very shortcut method to find the solution of the exact ODEs. So I'll write the heading. What is the shortcut method? Let's see. So what you need to do is that step 1 is what? You need to compare your given equation with what? With m dx plus n dy equal to 0 and find m and n as we have done in the example. You need to find this m and n by comparing your given equation with this equation. Then what you need to do is that then find del m by del y and del n by del x. Okay, then the next step is you need to find out these two quantities, del m by del y and del n by del x. Now what is the third step? Like if del m by del y is equal to del n by del x, we conclude that the given equation is exact. Okay, so this this you have done in the previous example also. So what is a shortcut? Now in the shortcut method, what you will do, you will if you find out that okay, my differential equation is exact because this condition is holding true, you will just write directly that integration of m dx, here treating y as constant, that means that you will integrate m with respect to x treating y as constant, plus you will only integrate the terms in n that does not contain x. So you will take the terms in n that does not contain x and then you will integrate it with respect to y and this will be equal to some constant c. So this will be the solution of your given exact differential equation. So let us see few examples to make this shortcut formula more understandable and applicable. So this is my example 1. You need to solve this differential equation. You know that how you need to start. You need to compare this differential equation with m dx plus n dy equal to 0. So compare what we have this thing. So therefore what will you get? You will get del m by del y as minus 4x minus 4y and del n by del y is equal to what? Minus 4y minus 4x. Now you can see that these both quantities are equal. This and this are equal. So what you can conclude is that therefore what you can say that del m by del y is equal to del n by del x. Now if this condition is true, what will you say? Therefore the given equation is exact. So I will write therefore the given equation is exact and hence the solution is given by its solution is what I have told you. The solution will be, I'll just write down that integrating m treating y as constant plus integrating terms of n not containing x. So I'll write terms in n not containing x into dy is equal to some constant c. This will be the solution of the exact differential equation. So let us see what will be in our case integrating m, that this is my m, so I need to integrate this with respect to x, and here I will treat y as constant, and then I need to see that what are the terms in n. You can see this is my n, and what are the terms in this n which are free of x, that is only this term. So I will only consider this term to integrate. So in the next we will consider just y square dy, and this is equal to c. So just integrate this keeping y constant. So what will be the value? This implies this is x cubed by 3 minus 4y into x square by 2 minus 2y square x plus y cubed by 3 is equal to c. So this will be the solution. If you want to more simplify this, this implies that what will be the final solution? X cube plus y cube minus 6xy x plus y equal to c. So this will be the solution of your exact differential equation. Now we will solve few more questions. So example 2, solve this differential equation. Again what we need to do, we need to compare this equation with m dx plus n dy. So I'll write, so what we are getting, we are getting m as equal to 1. This will be our m, and what will be our n? This will be our n. So I can write this as, this is my m and this is my n. So, and my n is e to the power x by y 1 minus xy y. Okay, so now let's calculate del m by del y. So this will be equal to, you can easily see that this will be equal to this. Now what about del n by del x? Finally you will see that you are getting to all the steps. So I have differentiated this with respect to x, and this is a first function and this is a second function. So this, and then so what I am getting del n by del x as this and del m by del y as this. So you can see that this both are equal, thus I can write del m by del y is equal to del n by del x. So therefore what will be the conclusion? Right, this implies that therefore the given differential equation is exact. Now you know how to solve the exact differential equation. So I'll write therefore its solution is, what will be the solution? You know that you need to integrate m dx treating y as constant plus n terms in n which does not contain x is equal to c. So this will be the solution. So let's do it. So what will be our m? This is our m. This is our m. So just write down 1 plus e to the power x by y dx, and plus just see what is n. This is n. Now no term is free of x. This one is also having x over here, and you can see that it is multiplied, so no term is free of x. So what you will write? You will write here there is nothing, and this is equal to c. So this implies that if you integrate this, what you are getting? You are getting x plus y e to the power x by y is equal to c. So this will be the required solution of the given differential equation. Now let us do another example. So the question is determine the values of a and b such that the following ordinary differential equation is exact, and after finding that you need to solve it. So this is my differential equation. So what you need to do is that you need to find out the values of this a and b for which this differential equation is exact. Okay. So let's see how we can do that. Now you know that for exactness, what is the condition? So we will use that. Just compare. You will see that this one is your m and this is your n. So I'll write down here m is y plus x cube and n is ax plus by cube. Now what you need to do, del m by del y you need to calculate. This is coming out to be 1, and what about del n by del x? It is coming out to be a. Okay, so for exactness, what is the condition? Del m by del y should be equal to del n by del x. This implies that a is equal to 1. If you equalize this, you will get a is equal to 1. So if you put this a is equal to 1 in your differential equation, your equation will become exact. Here you can see that you don't have any restriction on this value b. So b can take any value. So I'll write and b can take any value. Therefore, for a is equal to 1, the equation becomes exact and the solution will be given by integration of m, that is this, treating y as constant, plus only integrating only those terms in x which are free of x. So I'll just consider which term? This term. This is free of x. So I'll just write it over here. By cube dy is equal to c. This will be the solution. So this implies that I'll integrate this with respect to x, keeping y constant. So I'll get this. And then I'll integrate this. So I'm getting this. So this will be the solution. This will be the solution for the given differential equation. And here it will be exact if value of a is equal to 1. So now I'll give you two questions. After watching this video, I hope you will be able to solve these two questions. So the first question is solve this, and I'll write down the solution. That is the solution or answer for this question will be this. This is the answer for a part, and I'll write another question. This is y square ex square plus dx plus 2xy e to the power xy square minus 3y square dy equal to 0, and the answer for this will be, so these are the questions, practice questions. So I'll end my lecture 4 here. Thank you.